Yeah, I saw that. Is she sick or what's going on?
They don't know yet.
Sad. Okay. So moving on to one variables today.
It's easier than two.
I don't know. I mean, it's just different. So you could like one and not the other, and vice versa. Okay. So just remember what we've done in like past lessons. We have solved linear inequalities of one variable. So basically what I mean by that, linear is always like a variable to the first power. And it's still an inequality, still has one variable. So we've solved problems like this, like 2x plus 3 greater than 5, for example. Okay, how did we solve this?
Subtract
3,
by 2.
divide 2, you get x greater than 1. Okay, so most of the time to get out your one solution, when we were solving them like this, we were graphing on a number line.
And then you circle with dot.
Yeah, so since this one's greater than, do I know the circle or dot? Yeah, it should be a circle. I'm not including one, so I don't want to shade it in. And then am I shading the left side or the right side of the line? Right side.
Is it going to be graphing this one?
We're graphing.
Not that.
Yeah. So this is linear. Done this before. Now we're just moving up in the world, making the problems quadratic. Okay? So we're going to be solving quadratics that basically look like this. Say x squared plus bx plus c greater than 0. So this is in general form. We were going to solve this on the left side, okay? Because we want to find our x value solutions. So that way we can graph it on the number line, shade the correct region. So we need to remember can I actually solve a quadratic? There was many ways to solve a quadratic. Does anybody know one thing?
Formula.
Okay.
No.
So the most recent one was using quadratic formula to solve this. Let's just write down what is a quadratic formula.
Is it general standard and
Those are the different ways of writing a quadratic. This is how we're solving a quadratic that could be in any form. So that's one way to write a quadratic. What is another way? Good question. So quadratic formula works every time. We can use it to solve a quadratic no matter what. But, I mean, it's kind of a long and tedious process. Doing the square root, simplifying it, kind of takes a little bit of work. But it's like foolproof. It works every time. So that's kind of nice about it.
What is that formula?
I mean, there is vertex one, but that's not used to like, solve a quadratic. That's just a different way of writing a quadratic.
Give us a hint.
Well, we just did it last week, or this week.
I don't remember anything up to right now.
Oh, well, then I can't give you any hints then. There's one way that sucks. That is not user-friendly.
oh,
There's one that's the easiest way of solving a quadratic that we struggled with.
this is
What?
no, that's not Complete square.
So completing the square is the method that sucks. Probably won't ever complete the square if we don't have to. Yeah, because that's finding that C value of b over 2a, or b over 2 squared, I mean.
Is it a complex conjugation?
No,
No, okay.
that's just like simplifying imaginary numbers, that's not solving the quadratic. We have like 2 more weeks.
Number 2 is the only one that sucks.
Out of all the methods, that's not user friendly. That takes the longest. And most people can't set it up right. Yeah.
Radical?
What?
Radical? Isn't it radical?
I mean, kind of. We can square root both sides. So this only works if you're given x squared and not x. So if you have like x squared equals 4, the root both sides, then you get plus or minus 2. Okay, so that one's kind of nice. Square root both sides, I would say that's one of the easier methods, but then it doesn't work all the time. You have to have a specific quadratic, unfortunately. If we could square root both sides, that's just awesome. We have one more way, which is the very first thing. Very first way of how we're able to solve a quadratic.
What did you say?
There's one more way, and it was the first method we learned with how to solve a quadratic.
AC?
Bam. AC method. Or factoring. So technically AC method factoring, this should be the easiest way to solve a quadratic. Okay, we use factoring a lot. If you can do it like this, it's like 3 steps and you're done. Quadratic formula is like 5 steps. Completing the square is probably like 7 steps. Square rooting is like 2 steps, but then it's not always like that. Okay, so we're going to use these methods to solve the quadratic. I'm going to write one more thing down before we do this table. Okay. So those are the ways to solve a quadratic equation. Inequality makes it a little bit different because how many solutions do we normally get out with a quadratic?
How many what?
How many solutions? Yeah, so typically we get out 2 solutions. So if I connect this back up to our linear inequality, right, linear, we were graphing on a number line, we just plotted the point and shaded whatever direction it said. Now we have 2 solutions, so maybe I say it's like A and solution B. So then you're going to have a problem like, what part do I shade then? Right, because now I cut the number line into 3 parts into 2 parts. So, sometimes. Yeah.
Well, that's
So-
what we did learn.
Right, we have learned that we could shade in between these 2 numbers and outside these 2 numbers, which probably is going to happen 90% of the time.
Is there one kind of like, so when we do like the graphing and you shade the region, you shade from like B over or your A over?
Yeah, so to figure out what part we're shading, we're going to like test a point in each interval. So just like we're testing a point to shade on actual graph, we're going to test the points to plug in. And we'll see how this all works. But we wrote this down yesterday, less than or greater than is a circle on your graph, less than or equal to, greater than or equal to is a dot. Other than that, we're just putting it all together. Okay, so let's do one. We have 3 examples just to prepare you. Alright, so we have x squared plus 2x greater than or equal to 8. So we have 4 different ways of solving this quadratic. What would you like to do first?
Put them on one side.
Okay,
There's the check.
sounds good. I guess if I was doing it, I would probably first check to see if I could factor it. If I can't factor it, quadratic formula. That's probably 2 steps I would do. So if I was factoring, I have to identify like the AC value, the B value. So what's A times C?
-6 thirty.
Well, sorry, yeah, sorry. And then,
Okay, so then remember we have to ask ourselves, what multiplies to -8? That adds up to 2.
2 of them.
Okay? 2 and 4.
2 negative.
2 has to be negative to multiply to -8, and it adds to positive 2, so that works out. So do you remember how to set up the AC method?
Yeah, x minus 2, x.
Yeah, so since we don't have an A value, I can write it straight in factored form. If you have an A coefficient that's not 1, you have to write it in the 4 terms and then cut it in half. Okay. But since it's factored like this, I can set each part equal to 0 and solve for x. So x minus 2 greater than or equal to 0, and x plus 4 greater than or equal to 0. So it's solving for x,
add 2,
add 2.
you get x is greater than or equal to 2.
Yep.
And then you get x is greater than or equal to -4.
Okay. So it's basically solved. So most of the times our inequality sign should not be pointing in the same direction when we have our solution. And that's why we have to graph it and test which one of these has to like switch the other way. Okay? So on our number line, I can plot -4. I can plot 2. At these points, are they going to be circles or dots? Dots, because they're equal to. So like, if I was doing a linear line, basically we're saying I'm shading to the right. But that's actually not accurate. So we're going to test. So I guess I would test points on the left side of -4 and between -4 and 2 and on the right side of 2. So we're going to test 3 points since I have 3 different sections. So what number do you want to test first?
1. Oh, one of those numbers, -4.
Well, I'm going to choose a number on the left side of 4 and between 4 and 2 and on the right side of 2.
Okay, yes.
Okay, that's fine. So if we choose 2, I have to plug this back into the original one, so x squared plus 2x greater than or equal to 8. So I have 1 squared plus 2 times 1 greater than or equal to 8. Did I write that down right? Yep. Okay. So what is 1 squared plus 2 times 1?
2, 3.
So is that true or false?
False.
False. So basically, since 1 is between -4 and 2, every value between -4 and 2 is false. So I just, to make notes, that's the false section. So now I still need to check the left side and the right side. So what's another number you want to check?
-5.
-5. That'll work. So let's plug -5 into the quadratic. We have -5 squared plus 2 times -5 greater than or equal to 8. What do you say?
Scratch that 25%.
Okay. So 25 plus negative 10 is
Negative 15.
positive 15?
Negative.
Positive?
Positive means.
Okay. So is this a true or false statement?
True.
True. So this side is true. So since it's true, I could shade that side as well. So our value on the left side of negative 4 is true. And checking the last interval, what number do you want to plug in?
3.
3. So we have 3 squared plus 2 times 3, squared and equal to 8.
6 and 9 plus 6 is 15.
Which is true. And I'm shading that side. Okay. So that's my solution. So technically, which one of these inequalities do I have to change? Because I have x greater than or equal to 2 and x less greater than or equal to negative 4. So which one of those is inaccurate based on my number line? The second one. So technically, this should be less than or equal to negative 4 because I shaded on the left side of negative 4. So this is my solution. Yeah, so just so that way our inequality matches our number line now.
Okay.
Okay. Okay, I'm gonna do something. Okay. You don't have to write this down. But just another aspect of this. If we were asked to graph like y equals x squared plus 2x minus 8, we could do that, technically. I don't want to do the full graphing or anything like that, because technically we find the vertex and plot points and do all this stuff, and don't want to. What do I know about the graph of this? Does it open up or does it open down? Okay, and how do you know that? Yeah, the inequality is positive, so I know it opens up. And then I do have 2 points of my graph, technically, based on what I just did right there. So 2 and negative 4 are solutions. These are actually the x-intercepts in the graph. Okay, so I could plot negative 4. I could plot 2. Since I know it opens up, my parabola is like, woo.
Right, but you don't.
Okay.
And then,
So here's how this all comes together. So I could think about it on a graphical standpoint. So instead of this guy, we had x squared plus 2x minus 8 greater than or equal to 0. So on my graph, I can figure out where is it greater than or equal to 0, the x values. So basically the x-axis is cutting in half. Everything below it would be less than or equal to 0. Everything above it greater than or equal to 0. So I could look at my x-intercept, this is where it changes from less than to greater than. So on the left side of negative 4, that's why we shaded this guy because it's above the x-axis. Same thing at 2, my arrow is above the x-axis, that's why I'm shading to the right of 2.
I like that.
Yeah, so if this is flipped upside down, then I know I'm shading in between because the U part is above the x-axis instead. Okay? Mixing it all together. Just so that way, because there is one that's kind of interesting. It'll make sense when you think of the graph. Okay. Let's do another one. So we're going to solve this guy. What would you like to do first? Okay.
So you have half parentheses x squared plus 1.5 x plus.
We're not taking like a 2, that'd be 1.5, we're taking out half. So we're going up in value. So it should be 6.
Oh, yeah. And then, 4.
Where we divide by half is basically like 3 times 2, 6. Negative 2 divided by half is negative 2 times 2, which is 4. Yeah, so technically I could multiply 2 on both sides since I was 0. So then that half goes away, so I can ignore that piece of it. So now I have this quadratic without fractions, which is nice to look at. I don't like to look at fractions. And then my a value is 1 as well, so that's just icing on the cake.
We did that
That was a good start.
Oh.
Okay, now.
Now AC method.
Okay.
So you will be,
-4, 2 and 4.
2 and 4. So the numbers I'll multiply to 4 are 1 and 4, and 2 and 2. Neither of those add up to 6, like they're not big enough. So it's not factorable. So I can't do the AC method. Sadly. So I need to pick a different method. So I could,
could you do the complete square method?
yeah, if you wanted to.
What do you think?
No, you can complete a square, do quadratic formula. We can't square root both sides because we don't just have an x squared, we have x squared and x.
Yeah, let's try complete the square.
Right here.
Yeah. So that would be -4 over 2, which is 4. What? Oh, 6 over 2. Which would that be? 3, 9.
Okay. Technically, if we're completing the square, we should set it up correctly, so we found 9. So when we set it up with x squared plus 6x, we usually leave that gap, which we know now is going to be plus 9. We typically move the 4 over, and then we have that gap, which we know is plus 9.
Oh,
Yeah, I'm assuming Dylan do it then.
is it easier?
I mean, it's everybody's preference. You can do things different ways. You wanted to put the square, Dylan with the quadratic formula. Gracie, what would you have done? None of them,
I
just.
don't know.
Yeah.
This is good. I hate this chapter.
Me too.
What is next chapter?
I don't know, we don't
Like
do that
something
one next
better?
year.
Yeah, I have no idea. Check my things actually. Honestly, it's like fun and most look at like cubics and fourth degrees.
Hopefully it's better than this.
Okay, so now,
I thought we were done quadratic.
could you do, x plus 3 parentheses is less than or equal to 13.
Right. So left side we factored to be x plus 3 to the 7th power. Combine 4 and 9 to get 13. Alright.
Now can you,
Now we can square root. We just have a 2nd power. We can get rid of that.
right?
So we have x plus 3 less than plus or minus square root of 13. Can square root of 13 be simplified?
No.
Okay.
That's not a perfect.
Yeah, it's a prime number, so we're just gonna leave it. X is almost by itself.
Let's move 3 to the other side.
Yep.
So you have plus or minus is square root of.
Well, it's 3 plus.
Oh, yeah, yeah. You
Yeah. Negative 3 and square root of 13 can be combined, they're not like terms. So technically, this is my solution right here. Weirdly. We still want to do the whole number line thing. Yeah, so how do you think about this on a number line? So I would probably find the decimal approximations for this, just so I can figure out where the heck these are actually.
So actually, to figure out the square root of 13.
Yeah, so -3 minus square root of 15 is
Where we got all
whatever. And -3 plus square root of 15 is whatever the decimal is. Yeah.
I thought this meant that we're only supposed to get one answer.
Mm-mm. Completely square, you always get 2.
The
I mean,
negative,
what's the list number?
-3 plus the square root of 13 is 0.60555.
Okay.
3 and then the other one,
No,
-3.
you see, that was linear inequalities, which we've done before. We want to make it better with logic. So we get 2.
And then -6.605. Well,
0.605. Okay, but on my number line, I'm actually going to write -3 minus square root of 13. -3 plus square root of 13. But this helps us figure out what number I'm going to even test. Instead of taking a shot in the dark. Will I have a circle or dot?
You're going to have a circle.
On both of them?
Yeah.
Okay. So what numbers do you want to test?
Well, as far as the -1 goes, the -7.
Okay.
Can we just write them all out? So let's do -7, -1, and 1.
Okay. So we're all going to take one. So Bailey, you got -7. Gracie has -1. Dylan has 1. Here, I'll scroll up so you can actually see the quadratic here.
Well, mine's pretty easy.
Well, okay. What is yours?
Yeah, I got the hard one.
You plugged in 1. What number did you get?
Same thing that I got.
We
I
just
don't
have to plug it
understand what you mean by
into. We just have to plug it into x squared plus 6 minus 4, right?
Yep.
You just do that.
Oh.
Okay, thank goodness. Okay. So
Why are-
I mean, you can plug it into the fraction. You get the same thing.
um, $87.
Really?
Not too much.
Yeah.
Mine's -4.
Is that not right?
I don't think so.
Mine's -5. I mean, I guess that would make sense.
Oh,
if
hold
mine was-
on. It's actually 3.
Okay. So you got 3 less than 0.
Yeah.
What did you get?
I don't know yet.
So mine's false. His is false.
So I put the
It'll
one
be shaded in the middle, won't
axis
it?
obviously.
1 squared.
Oh, it's not one. Okay,
6
but
times
it's- okay, never mind. Nice.
Come on, dude. It's hard.
Okay, it'd be 1 plus 6 minus 4.
Which is
Actually, the one is
7 minus 4 is
Hey, Bill. Which is the one to, oh, for all wrong.
well, 3 is less than 0. That's false, right?
false. False.
-5.5
Oh,
is
that's
less
true.
than
That's
0.
true.
Oh, yeah, mine's negative.
Yeah, that should be true. This one's false.
So that's inside, right?
Yeah, so we're shading right there.
Okay. Hold on.
See, you do shady, they're only inside the outside. Just different.
So then our inequalities, we can write. Oh gosh.
Okay, we have another one after this.
Well, yeah. But I want to write my solution now, based on interval. So x greater than -3 minus square root of 13. Or x less than -3 plus square root of 13.
Just do the top one.
What?
That's it. Never mind. That's it?
Yeah. So -3 minus square root of 13 or larger. So it's greater than -3 plus square root of 13 or small. Whew.
No.
Okay. Last but not least.
Okay. We go.
And let's use the quadratic this time.
Do the quadratic formula?
Yep.
Okay. So A values. A, B, and C are.
A is 9, -24, and 6. I beat you, so.
We're in competition
Dinner
right now.
race.
Mm-hmm.
So you're gonna have x equals, since it's a negative, we would actually, we could change it to positive 24. And then, plus or minus the square root of,
B squared minus 4AC.
yes, so -24 squared minus,
Minus 4
and then,
times 9 times -16.
There's positive 16.
Or divided by 2 times 9.
I forgot that. I should.
so usually.
576. That's my guess.
Oh,
Am I right?
I am, I'm trying. Get 576.
How do you know that?
Shot in the dark. Sounded right. So minus whatever 4 times 9 times 16 is. 2 times 9 is 18. I got that one.
Yep. Wait, what are you doing?
Multiplying 4 and 9 and 16 together.
Oh,
3.
Are you sure?
Big plus though.
I don't think that's right.
4 negative times 9. Oh,
I got
576.
-576.
I don't know what I put in last time. But it's
But if it's a
plus.
-576 and you're already subtracting it.
I only have
Oh.
one negative sign in that sucker.
Oh.
4, 9, 16.
I
It's
just
just 9,
put,
6,
when I
6.
put my equals, I thought it was
You're right. Okay.
So basically I have the square root of 0. So like plus or minus 0, not doing anything. We just have 24 over 18, which simplifies.
The 12 over 9 is going to be 4 over 3. Right?
Okay, so we got one solution in this case, which happens not very often, but it can happen. So we still want to do the number line situation. So we have 4/3. Is it a circle or a dot?
It would be a circle.
Circle? So I need to test both sides, figure out true and false.
Okay, let's do 1, 2, and 0.
Okay.
Once you figure out one of them, you should.
So 0,
What do you put 0 back into?
the original, minus 0 squared, and then minus 24 times 0 plus 16. That was less than 0.
Ooh,
So the first two terms cancel.
B16.
maybe 16.
So 16 less than 0.
False. So
Fine.
we know it's not on that side.
Then plug it into 9, 2 squared, minus 24 times 2 plus 16 less than 0.
Okay, 36 minus 48 is 4.
Okay?
False. And it's also false.
So it's also false.
Do not shade.
Yeah, we can't shade anything.
Oh.
So,
Do we do something wrong?
nope. So our answer is actually no solution.
Because would it be underneath?
A lot of work to say no solution.
If you were to shade, would it actually be underneath? So that's why you don't shade the thing?
Yeah, so if we think of it as a graph, technically that 4/3 is my vertex and it's sitting on the x-axis. So to have this point on my parabola, is my parabola opening up or down?
It would be opening down.
Up.
Wait, yes.
My a value is positive, so it should be opening up. So basically we're saying I want all the values less than 0. So is any part of the graph below the x-axis? No. So that's why we get no solution.
So I guess that's a faster way to figure that out.
Oh, I just thought it was gonna face down.
Yeah, if it face down, then you'd have like all solutions are, like all real numbers are the solutions.
Nice.
Will we have that?
Yeah, I think there's like 1 or 2 that are like weird like that. But if you still do like the whole number line thing, it gives you the answer.
Well, will there be any where it says like the whole line? No.
I mean, you could have a line that's all false, which we had. You could have a line that you shade the entire.
So you can have that?
You can write just like infinite solutions. Then. Yeah. Okay. That.
Why?
Oh, whoa.
Why?
I have a quiz. Here's your quiz. You can correct it if you want to. If you're not going to, you should go back to me.
It's in passing, right?
What?
I think that.
Okay. Oh shoot, I shouldn't have done that.